Let's have a look at question 4. So you should have attempted this by now, and I'm going to look at the saving formula just to see what they represent. So what the x is the number of weeks. So the number of weeks, the number next to the x will tell you how much they're putting in per week. So for Robert, he's putting in €5 per week. For Barry, €4 per week. And if we jump down to Annette, 12x means Annette is putting in €12 every week. Now the number on its own with no x next to it is the amount in the account already. So Robert has a 0 there. That means there's nothing in Robert's account when he starts saving in the first week. Karen has 300 on its own, so that means Karen has 300 in her account at the start when she starts saving. And then Alex and Stephanie both owe money. Alex owes €50 at the start, or not Stephanie, Stephen even owes €20 at the start. So let's have a look at Robert and we'll see how his saving will progress week to week. So at the start, we can see that he's got 0 there. Now the 5x means he puts in €5 every week. So at the end of week 1, he's going to have 5 by 1, €5. At the end of week 2, he's going to have 5 by 2, he's going to have €10 in his account. At the end of week 3, he's going to have 5 by 3, €15 in his account. That means that every week the money in his account is going to increase by €5. If we go to Barry, Barry starts off with €40. So on week 0, Barry has €40 in his account. At the end of week 1, Barry has put €4 in, so he's got 44. At the end of week 2, Barry's put in 2 €4, so 8 in total, he's got 48, and so on and so forth. If we jump down to Alex, Alex has minus 50 in his account. So after 1 week, Alex puts in €8. That means Alex will have minus €42 in his account. After 2 weeks, he puts in another, he'll have minus 34, minus 26 after 3 weeks, and so on and so forth. Now let's have a look at Dinah. Dinah has €300 in her account, but there's nothing multiplied by x in the formula, meaning that she's not putting any money away. Annette is the other special case. Annette has got nothing in the account because there's no number there, and there's no 0 there either. And if there's no 0, we can imply that it's there, but it's hidden. So she starts off at 0, and then every week she puts in €12. So every week she's going to have 12, 24, 36 euro in her account. It's going to increase by 12 each week. All right. Algebra 3. So we need to deal with more terminology, and we need to deal with like terms. Now we use like terms because we need to put those together when we're adding and subtracting in algebra. So down the bottom right hand corner, like terms can be added or subtracted together. So let's have a look at this. We have 2a plus 3b plus 4a plus 4b. Now the like terms are the things with the a in it. So we've got a 2a and we've got a 4a. The other like terms, the other two terms that are like each other but are different to the 2a and the 4a, are the 3b and the 4b. And what we can do is we can add these together. So if I had 2a and a 4a, I would have in total 6a. And if I had 3b and a 4b, in total I would have 7b. Now that may make sense to you right now, but here's how I think about it. On the left, we have a sentence, and we want to make that sentence as efficient and as short as possible. And the most efficient way to write that sentence is as it is written on the right. So in my head, I can substitute, instead of A, I could say apples. Instead of B, I could say bananas. And if I was to read the sentence on the left, it would mean that I've got 2 apples and 3 bananas and 4 apples and 4 bananas. And that's not a very efficient way to say it. If I have 2 apples and 4 apples, basically I've got 6 apples and 7 bananas. And on the right then, it's a much more efficient way of thinking about it. So I'm going to use the same thing with the next one. So what does this say in terms of apples and bananas? Well, I have an A and I have a 5A. Remember, A is the same as 1A, so I've got 1 apple and I have 5 apples. So I've got 6 apples anyway to start with. Now I've got a minus 3B because the sign is always attached to the number. So it's not 3B, it's minus 3B. That tells me that I owe 3 bananas to somebody. Now, on the right-hand side of that, then I've got plus 4b. So I have 4 bananas and I owe 3 bananas. So that means I have 1 banana. So I should have 6 apples and 1 banana. And remember, 1b is the same as just b. Okay, so remember, like terms can be added together, unlike terms then have to be treated separately. So I'd like you to give these guys a go. Pause the video, and here are the answers. Number 1, 2 apples and 5 apples, 7 apples. Number 2, 7a. Number 2, 17x. Number 3, 4x. Number 4, 2 yellow submarines, and I owe 2 yellow submarines, means I have just 2 yellow submarines. Number 5, 1 peach and 8 peaches. I've got 9 peaches, so 9p. 6, 3m. 7, 8p. And 8, 4t. Okay, if you didn't get them, go back, try them again, and listen to the video once more. Alright, this is probably the biggest problem that guys have, and that is, what does the square and the cube mean? Now, we've already done this in numbers. In algebra, it means the exact same thing. So look at the top box there. 2 to the power of 2 means you're multiplying the base, which is the big number, by itself twice. 2 cubed, you're multiplying the base, which is the 2, by itself 3 times. And 2 to the power of 4, you're multiplying the base, which is 2, by the indice, which is 4. So 2 is multiplied by itself 4 times. All right, we've come across that before. Now go to the bottom box. Okay, we start with the x. The x means it's 1 by x. And we can write that as a power. We can say it's x to the power of 1, because it's just x on its own multiplied by itself once, which is just writing it as x. The next one, x squared, is x by x. That can be written as x in brackets in both cases. We're working across horizontally. It's known as x squared. The next one, x to the power of 3. It means x by x by x, which is the same as x cubed. Obviously then there's a pattern here. X to the power of 4 is x by x by x by x. 5x squared is the next one. It's 5 multiplied by x multiplied by x. Can be written there as 5 open and close bracket x open and close bracket x. The last one, 5x squared plus 4 is how we'd read that. It's 5 multiplied by x, and the result of it is 4 is added to it. Now, what I want to mention here, and this is essential, the x's and the y's we already know are different terms. A's and b's are different terms, so different letters will be different terms. But x's and x squareds are always different terms as well. X's, x squareds, and x cubes are considered different terms. And likewise, a's and a squareds are different terms, b's and b squareds are different terms. So we're going to have a look at just identifying different terms in this. So what I'm going to do is look at the numbers first. So the numbers are a particular term, and I've circled that's where the numbers are. So if I had an algebraic expression that I needed to add and subtract, I would add and subtract those 4 numbers together while ignoring everything else as I'm doing it. The next thing I look at is just the x's. So remember, x's and y's are different terms. We don't put those together. Also, x's and x squareds are different terms, and x's, x squareds, and x cubes are different terms. So if I had an algebraic expression, I'd be putting those x's together and I'd be adding and subtracting them. And we can do this as well. So I've got a 3x and an 8x, 11x, and another 2 is 13x, and minus 5 is 8x. So in total there I've got 8x. I'd put the y's together separately. Okay, so if you add those, what you'd end out with is, I think, 10y. They'd be different to everything else. Likewise, the x squareds are different terms to everything else. The y squareds are different terms to everything else, and the one I haven't got highlighted there are the x cubes. They're different terms as well. So how does that work when we're adding and subtracting? Well, what we need to do again is identify the like terms. Remember that the x's and the x squareds are considered different terms. So we've got a 2x squared and a 4x squared. I'll have a 6x squared when I add those together. I also have 3x and 4x, so I'll have 7x, and when I simplify those, I will get something like that. Okay, back to the whole idea of representing these with sentences or words. If the x's were xylophones, that's a musical instrument, the x squareds could be square xylophones. So they're kind of related, but they're not the same thing. Xylophones and square xylophones. And if I read the left-hand side of that equation from left to right, it would say I've got 2 square xylophones, I have 3 xylophones, they're the regular ones, I have 4 square xylophones, and I've got another 4 regular xylophones. So if I have 2 and another 4 square xylophones, I've got 6 of those. And if I have 3 xylophones and 4 xylophones, I've got 7 of those. Hopefully that makes sense. All right, second example. Remember now we've got x squareds and x cubes, and they're different terms. Let's start with the x squareds. So I've got 2x squared minus x squared is 1x squared plus another 3 is 4x squared. Then I've got an x and I've got minus 1x cubed. So I can't simplify the last 2 terms, but the first 3 can be simplified to give me 4x squared plus x minus x cubed. Okay, if you need to go back and look over those again and listen to what I say, great. If not, let's have a look at this one. All right, so I've got x squareds and I've got y squareds. So those are the only 2 different terms. Okay, 2x squared minus x squared plus 3x squared. I have 2 square xylophones. I owe 1 square xylophone. And I have a further 3 square xylophones. So I definitely have 4 square xylophones. I'll have 4x squared. And then I've got a y squared and a y squared. I've got a yogurt squared and another yogurt squared. So that's 2 yogurt squareds. There should be a plus between those. We should have 4x squared plus 2y squared. Okay, pause the video, try these. Here are the answers. In the first case, 8x squared. Second one, minus 1x minus 1x. If I owe a xylophone and I owe another xylophone, I owe 2 xylophones, so that's minus 2x. The next one, put the like terms together. 3a and 4a is 7a. And then we also have 2b and 5b, which is 7b. So I get 7a plus 7b. Don't forget that plus. The next one, 5x squared plus 9x. The next one, 6x squared plus 8x cubed. Number 6, 7w minus 2v minus w minus v. So we have 7 Wonka bars of chocolates minus 2, Venuses, minus 1 Wonka bar of chocolate minus another Venus. I have no idea what a Venus is. So 7 Wonka bars of chocolate minus 1 Wonka bar of chocolate is 6 Wonka bars of chocolate. And if I owe 2 Venuses and owe another Venus, I owe 3 Venuses. That'll give me 6w minus 3v. All right, the next one, a little bit more complicated. 5ab minus xy plus 3ab plus 3xy. So there are 2 different terms here. There's the ab term and there's the xy term. AB I'm going to call awesome bananas. XY are xylophones that are yellow for me. So 5 awesome bananas minus 1 xylophone that's yellow plus 3 awesome bananas plus 3 xylophones that are yellow. Now awesome banana wise, I have 8 awesome bananas. If I owe 1 xylophone that's yellow and I have 3 xylophones that are yellow, I'd have 2 in total. So my answer would be 8ab plus 2xy. Now if you didn't get those, go back and try them again. Make sure you can do them because this is really important.